Okay, so a few of you have messaged me and said that you're struggling with the idea of how to set up preceding and following or centered interval. And some of you have even messaged me and said sometimes you're using the difference quotient for preceding and following. First off, to just mention that, preceding and following and difference quotient are actually the same thing. The difference is that with difference quotient, we're actually given a formula that we have to follow, and we're going to use a width typically of 0.01. With preceding and following, if a question asks that, you can go with any interval size you want. So you could go with an interval width of 2, you could go with an interval width of 5, you can go with an interval width of 0.01. We don't really want to see you go larger than 1, so try to keep it less than 1 because the larger the interval size you have, the less accurate your answer is going to be. So that's why if you're working through these questions and you're not necessarily matching up with the solutions in the back, it's because we're giving the most exact answer. And remember, you're just making an estimate. So if you're struggling with that, you can contact your instructor and send them your work, and they can maybe take a look at it and figure out where you've gone wrong. Okay, so let's just say that we have a function. I'm just going to make up a random function here. Let's say f of x equals 5x squared plus 4x plus 3. Now, I'm not going to use this for any calculations, but let's just say that this question said to us, find the instantaneous rate of change. Actually, the question wouldn't say find, it should say estimate the instantaneous rate of change at x equals, let's say 14. Okay, so if we're doing preceding and following, there's a few approaches you can take. The most important thing is that you keep the same interval width. So you could go 13 to 14 and then 14 to 15. So if you were to do that, you're going to go f of 15 minus f of 14 over 15 minus 14. That's your preceding, and then your following would be f of 6, sorry, that was not the preceding, that was the following. F of 14 minus f of 13 over 14 minus 13. And then your following would be f of 15 minus f of 14 over 15 minus 14. And then you're going to take the average. How do we get f of 14? Remember, you got to plug that in. 5 times 14 squared plus 4 times 14 plus 3, etc. You could go 13.5. I'm just going to write an or here. You could go 13.5 to 14 and then 14 to 14.5. The key concept here is that notice that the interval width is the same, 0.5, 0.5, or in that case there, 1 and 1. You have to be consistent, and it's got to be centered around the point that you're trying to find the instantaneous rate of change at. For centered interval, you've just got to be centered around that point. So we're talking about 14, right? So we could go all the way from 13 to 15. Centered interval is always the easiest one to choose because basically all you're doing is you're taking the slope around a point that's centered around it. So I said 13 to 15 because it's centered around 14, right? 13, 14, 15. There's 1 unit in between these two, and there's 1 unit in between those two. And they have to be both in between the point that we're trying to find the instantaneous rate of change at. Conversely, you could have gone, okay, and I'll just draw this out quickly. To find it, you're just going to simply go f of 15 minus f of 13, or 15 minus 13. This tends to be the most, or the least accurate of the 3 methods. When you're asked which one's the most accurate, difference quotient is probably your best answer, but you could argue preceding and following with a really tight interval. So if you ever encounter a question like that, just kind of remember that it's probably not going to be centered interval, because that's essentially just taking a slope randomly around that point. So you also could have gone 13.5 to 14.5, because that's nice and centered around 14. There's 0.5 distance there, there's 0.5 distance there, or width size. And that's kind of the key idea. So if you're struggling with this still, comment in the threads, let me know what you're not getting. It's really not that bad. If you're struggling with it, you might be overthinking it. You're always just looking at this point and saying, okay, if it's preceding and following, I need to find the slope before, so something to 14, and then I need to find the slope for something after, so 14 to something. And the distance between the preceding and the following has to be the same. So you could go 13 to 14, 14 to 15, you could go 13.5 to 14, 14 to 14.5, you could go 13.9 to 14, and 14 to 14.1. That would be a width of 0.1. Centered interval, it's the same idea, except we're only taking one slope, nice and centered around. So again, this is the easiest one to do because it involves the least amount of work, and you don't have to take an average at the end. Alright, so hopefully this is clicking. If it's not, that's okay. Either contact your instructor or just comment within this thread, and we'll see if we can clear up any confusion you're having. Alright, thanks.